Okay, part 2 of chapter 4, section 5 is just the back of the sheet here. On the first page, we did all the exponential equations, and now we're going to switch gears and we're going to talk about solving logarithm equations. And to me, I'm going to be honest, I think these are easier, but that's just me personally, I guess. It's just, it's less steps and it's less to remember. You're basically going to do the same steps every single time. Your first step is going to be to condense this into one single log on one side, okay? So just right off the bat here, the first thing that I see is that this is being subtracted. So if I want to condense what's on the left side, so we're talking about these two, then this is a division problem. You're going to have log of x plus 6 being divided by, and actually I kind of wrote this wrong because if I'm condensing it, I want it to just simply be one log here. So x plus 6 divided by x plus 2. And now we're going to still say that this is equal to log of x, okay? But I want you to think about this. If we were to divide log on both sides, because there's no rule saying we can't do that since they're both log base 10, I can actually divide both sides by log, okay? And if I do that, that just simply gets rid of the logarithm. So now I have x plus 6, here, I'm not going to put parentheses around that just yet. I have x plus 6 over x plus 2 is equal to x. So, looks a little bit better. We still have that problem of solving x to get it on one side by itself, and it just so happens to be that we got rid of the logarithms just to come up with a rational equation. But it's the same kind of problem that we did in chapter 1 now. If we want to rationalize this equation and try to get rid of, we need to get rid of the denominator, the x in the denominator. Then the first thing that we'll do is we'll multiply both sides by x plus 2. Just multiply whatever is in the denominator on both sides. That's going to get rid of that, leaving us with x plus 6 is equal to, and then over here on this other side, we'll have a quadratic. But it's going to be okay, I promise. All right? And here we go with these quadratics again, but we're not, college algebra, we're not going to get rid of them. To solve a quadratic, which should be, we should be able to do that in our sleep now, right? We're actually going to subtract and get 0 on one side. So we'll have 0 is equal to x squared, hey baby, hello, plus x minus 6. Y'all hang on one second. Okay, I'm back. He came in and he said, I want to help Mama color on her screen. Okay, but you'll have x squared plus x minus 6, and, luckily for us, this is factorable. Two numbers that would multiply to give us negative 6 and add to give us 1 are x minus, or x plus 3. X plus, it's a positive one, so x plus 3, x minus 2. And then, of course, we'll set both of these equations equal to 0, and that'll give us one answer is negative 3, and the other answer is going to be 2. All right, and they can have two answers. It is possible for us to run into one that could be extraneous. For example, this particular problem couldn't have an answer of negative 2 because it would cause this down here to become irrational, or, what's the word I'm looking for? It would have a 0 on the bottom, so undefined. There we go. But in this case, we got a positive 2, so we are good to go. All right, let's take a look here at our second problem. This one to me is actually maybe a little bit easier because you only have a logarithm on one side to deal with. So we really just need to condense everything over here on the left. So of course, when you're dealing with logarithms, if they're being added, that's the same thing as multiplying. So we're going to be multiplying these two binomials together. And of course, when you multiply binomials, you're either going to be doing FOIL or, the box method, whatever you prefer. I'm going to FOIL this. All right. And then we'll just continue to condense. So we'll have 3x squared minus x minus 2 is equal to 1. Okay. It still doesn't look pretty, but we have one logarithm with, just one logarithm is equaling to just a simple number over here, and it's got a base of, remember, if it's not listed, this is actually base 10. So as ugly as this thing looks, it's actually going to be pretty simple to solve. If we can get this to this format, to where we can either cancel out the log on both sides or we have one log on one side, then you can rewrite this from logarithmic form, which is what it's in right now, to exponential form. Okay, so we're going backwards from what we were doing on the front side of the sheet. So if I rewrote this as an exponent, and it would actually be 10. Uh-oh. No, what happened? Don't fail me now, computer. Hold on. Get the mouse going. There we go. I think. Maybe not. All right, there we go. It would actually be 10 raised to the first power is equal to all of this stuff right here. So 3x squared minus x minus 2. Now, what is 10 raised to the first power? Well, it's just 10. So really what we have here is we have another quadratic. And of course, just like with every other quadratic, we need to subtract and make sure it's equal to 0. So this is actually going to be 0 is equal to 3x squared minus x minus 12. Okay? This problem is, it could be a slide and divide problem. However, I'm going to tell you, since I've already worked it out, that this is not going to be a slide and divide problem. You're not going to find those two factors, unfortunately. So you can either complete the square or do quadratic formula. And I know how we all feel about completing the square here. So I'm just going to quadratic formula this thing. Okay. Making sure I have enough time. So the quadratic formula, come on, is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2a. In this situation, our a is 3, our b is negative 1, and our c is negative 12. So we'll have x is equal to negative 1 plus or minus negative 1 squared minus 4 times 3 times negative 12 over 2 times 3. Okay, now for time reasons, let me just, I'm going to sort of kind of just rush through it a little bit because I know you guys already know how to solve a quadratic, or at least I hope so. But this is as far down as I could get it. You actually cannot reduce, oh, that was a bad circle. You cannot reduce the square root of 145 any further, so we're just going to leave our answers such as this, okay? Or such as that. Now, let's keep going here and see what this next problem has in store for us. Oh, this is a fun one, right? We have, first of all, we've got natural logs, and we've got a natural log on both sides. So it's like, okay, where do we go? Where do we even start with this? What do we do? Well, the simplest way to put this is whenever you have, I'm sorry, guys, let me pause for just a second. Okay, that's what I thought. I did make a boo-boo, and I'll try to change this on your notes, but there's a boo-boo on my notes here. First of all, this should say ln of x up here at the top, and I'll make sure to change that before I add it to your Canvas. But the first thing that I want you to know before we get started with this is that anytime you are given e raised to the ln of x, then essentially the e and the natural log, or the e raised to the natural log, is going to cancel itself out. That's the same thing as just x. They just cancel each other out because a logarithm with a base e is the same thing as a natural log. So technically, you're just, it's almost like 1/1. It's canceling itself out there. So let's clean this problem up just a little bit. This is going to give us the ln, oh, hang on, I got a hug from a 4-year-old. Whew, all right, I told him, I was like, okay, last problem, we can do this. But we're going to have the ln of x now, since that just canceled itself out, minus the ln of x minus 3 is equal to the ln of 2. Now, just like with our first problem, our goal here is to condense this till we have, you know, an ln on both sides, just one ln. So we do want to condense all of this stuff here on the left. So when you're subtracting, that's the same thing as dividing. So here we go, I did it again. Uh-oh. So we're going to have the ln of x divided by x minus 3 is equal to the ln of 2. So kind of looks similar now to the very first problem in on the back side of this notes that we were working with. Since we do have an ln on both sides, it's the same thing as the log. We can literally just divide both sides by the ln, and that will leave us with a rational equation. Don't you just love these quadratic rational equations? The good news is that this one's actually pretty simple. You know, to get the x out of the bottom of this denominator, we've got to multiply both sides by the denominator. And that will leave us with x is equal to, and then we'll just distribute the 2. So 2x minus 3. And, you know, hopefully from here you're like, ooh, okay, got this, I can do it. And I actually made a mistake myself here. This is supposed to be 6 instead of 3. But from here, if you subtract 2x from both sides, you'll get negative x is equal to negative 6. And then last but not least, just make sure, not negative x, but divide by negative 1. And that will give you x is equal to positive 6. Now, just like with other problems here, make sure that your answer is not extraneous. Of course, in this situation, our x had to be, it could not be 3. X could not be 3 because that would leave us with an undefined solution. So as long as you don't get your, your x as a 3, then we're okay. And guys, that is it. I will try to post maybe a couple more examples if you need them, or we can go over some on Zoom. All right. Homework and tests, I'm looking to be due on April the 22nd, so that gives us a week from today. All right, y'all have a good day.